Hi, everybody. Um, just hi from Australia, where it is now 3 a.m. So forgive me if I'm a bit jittery. I've been caffeinating a little bit. All right. So, as Lynn mentioned, I work with our cloud infrastructure teams to deliver all the things that our internal developers need to have their services communicating with each other and the world securely, reliably, and effectively. Um, there is an expression that says that the proof is in the pudding. I want to set the expectations right there. There will be no pudding. Atlassian does not run Istio in production today. But that expression, the proof is in the pudding, that makes absolutely no sense to me. How would anything be inside the pudding? So as a professional, I looked it up. Thanks, Merriam-Webster. The expression originally was the proof of the pudding is in the eating. So let's see what we can do in terms of eating. So what we're going to do today is go through a little bit of a tasting phase. We're going to talk about the user stories that led us in that journey, and basically what our developers internally want to get out of this pudding we're talking about. The next step is going to be to figure out the ingredients that we need. So basically, we covered the journey we went through to decide on our ingredients. In this case, the data plane or the proxies that work best for us. And then finally, we will talk about how we decided on which recipe we are going to use to turn our ingredients, the proxies, into a hopefully delicious pudding by adding a control plane. The foodies amongst you might have recognized the dessert that's pictured there as the very famous Eton service mess. My hope is that by sharing what led us to decide to use Istio, it will make it easier for you, those of you that do not use Istio in prod today, to decide if and when Istio might be right for you. All right, so let's get to the tasting. We talked to our internal developers and all stakeholders around the company to ask them what they expected the platform to solve when it came to service communication. The main personas were the service developer as a consumer or provider of services, the service operator. Because we operated in a you build it, you run it model, generally it's the same people, but they have different needs at different times of the service lifecycle. And then the platform operator, that's mainly us and the teams that build the platform. We collated all of those, we grouped them by teams, all categorized them, the various teams, developer experience, cost, security, trust, operations, performance, reliability. We analyzed all those stories, and when we broke it all down, we came down to the following. Let's start with the cake. That's the things that the developer wants the most. That's the highest priority things they want. So developers want to have their HTTP client and server properly tuned so that they get better reliability and performance. You might be surprised, but these days still, like the default JVM HTTP server is not really well tuned. It doesn't know what the right values are for things like keep alives and connection pooling and timeouts and so on. So those things, the developers want us to provide same defaults that they can tweak and tune if necessary. Another thing that developers really want is to have what we call an API facade, because it's kind of an internal API gateway, but it's not really, they don't actually want the gateway aspect of it. Today, quite a few of our development teams run internal API gateways, but that's because they want multiple services to look like one with consistent authentication, rate limiting, etc. If we could give that to them without the actual gateway, they'd be even happier. Then there is service discovery. Basically, developers don't want to deal with DNS, and they just want to know that they call service X, and then they want service X to decide how traffic gets to them. This helps with also dependency mapping. It gives a better developer experience. It's easier to operate, and we can create trust because we can explicitly say these services talk to each other, and this is where the data flows. Authentication is also something developers typically want because we have a standardized mechanism to do authentication internally. There is no reason why we can't externalize it from the code of each of the services. Some other things that are in the high priority list in the cake, people want gRPC because they want things to be fast. Some services, not all of them, really need things to be fast, and that's where gRPC definitely provides an edge over REST. People want rate limiting, people want to get metrics from their services, And they want failures to be handled as well as possible. So things like retries, health checks, circuit breaking, they want to get that from the platform to improve reliability. On top of the cake, the medium priority items are the following, the top ones. So they're authorization. Authorization is very important, but generally it's done in the service code. Moving it out of the service code is more of a nice to have for the devs. Security, they want it a little bit more than the devs because that allows them to get a holistic view around authorization across the platform. Now, something that's a little bit more Atlassian specific is the idea of support for tenanted sharding. It's really because in order for us to run hundreds of thousands of instances of our products, Jira, Confluence, etc., we need to distribute our customers over separate shards or cells or partitions, depends how you want to call them. And each of those partitions are connected to a specific set of data stores. So a particular customers need to land on a particular partition or shard. Internal services don't want to know which shard they have to talk to. They just want to be able to say, hey, I'm talking to Jira, and the proxies figure out basically where the Jira for that particular customer lives. Cost control is also a concern that's reasonably high because currently we pay actually a few millions per year in cross-AZ cost and ALB and ELB costs. If we could do away with paying those and still deliver the same kind of features and reliability and so on, obviously that's something that we would like to do. Also, support for chaos engineering so that we can verify that our services behave the way we want when bad things happen is also something that's highly sought. And then finally, the little things that developers still want are support for tracing in the cross-service calls. We already have tracing ID assigned to all requests, and the service code can already emit tracing events related to those IDs, but it would be also nice if the proxies actually added tracing events whenever calls are made. Service injection, that's the idea that I can get my the version that I'm developing on directly inserted into the infrastructure. So that I can get some requests sent basically to my laptop or my local dev environment, so that I can see how it integrates with everything in dev, staging, production. Well, not production. And then two other small things that are improvements to the developer experience is mirroring, so that I can send a copy of the request to a different service version and observe it with real traffic, and tapping, where I can sniff targeted exchanges and see them in clear text for troubleshooting. All right, so the use cases in your org may vary a little bit. They may not be the same as the ones that I've just called out. But what's really important is that what you're actually trying to solve, the functionalities you're trying to deliver, stay top of mind. Our developers do not actually want a service mesh, at least the ones I've come to, they don't care about service mesh. They just want us to solve some of the problems for them and help them ship their products faster and better. So we'll come back to those use cases later and see how they do with some of the solutions. All right, so next step, to make a pudding, you need milk. To make services communicate, you need proxies. Chances are that your organization has a history of using various proxies, that is as long as the organization itself. Atlassian is no exception. 6 years ago, we had our own data center where different parts of the businesses ran Nginx and AJ Proxy, and then we replaced AJ Proxy with a vendor product called VTM, Virtual Traffic Manager. And then 4 years ago, we started moving most things into AWS. So obviously, we started dealing with ALBs and ELBs, so application load balancers and elastic load balancers. We also had to build a proxy that was dedicated to our new sharded architecture in AWS. So we based it on OpenResty, which is Nginx and Lua. We also built an API gateway based on Zool. And then through product acquisition, we added some Varnish proxies, and we reintroduced AJ Proxy. And of course, Nginx and VTMs are still around. So as you can see, we have a vast sprawl of proxies. So we had to standardize, of course, right? So you all know the stories. So 2 years ago, we decided to introduce a new proxy solution, Envoy. the main reasons why we did that are observability, performance, streaming config, extensibility, ecosystem. Chances are I don't need to sell you on Envoy. And effectively, we've been very happily using it in prod for over 2 years, and it's been doing great. We're using Envoy in two distinct ways. One is when we started out with Envoy at the edge, pretty much all solutions out there were extremely focused on Kubernetes and barely any worried about the edge. This is why we decided to build our own control plane, simply to be able to distribute configs to the set of autoscaling instances that we had behind NLBs at the edge. We wanted the platform to be self-service, so developers could describe the kind of public edge that they wanted with a few lines in their service descriptor, and have that safely streamed into a config change applied to those edge proxies. So the XDS API was a great fit for that. And this has allowed us to build a lot of the expertise running Envoy at scale and also using the XDS API. The other use case is between services. Our internal PaaS, our internal platform as a service, runs largely on the technologies that were the best building blocks in AWS when we started it about 5 years ago. So that's autoscaling group of EC2 instances fronted by an elastic load balancer, managed as a CloudFormation stack with extra resources like RDS or Dynamo associated for data stores, and also a few other things. Kubernetes wasn't really a viable solution for us at the time. It was still in its infancy. So we started introducing Envoy as a sidecar on every EC2 instance that are in those autoscaling group, and we added it as a transparent ingress proxy. Our very first feature was to standardize the ingress HTTP server and generate better metrics than what we could get from the ALB. We've been adding more and more features as well as supporting egress, though egress is not transparent. Developers need to change their code to stop using the DNS name of the service they want to call, and instead pull an environment variable that matches that service name and inject it into the service. In order to minimize risks, services are mostly immutable, and new versions are rolled out as new deployments with extra guardrails. So far, we've applied the same principle on the Envoy proxy config that's co-located on all those EC2 instances. This means that the config is rendered once when a new deployment takes place, and then that rendered config is populated as a file on all of the EC2 instances. So that's basically purely static config. We don't use XDS in that scenario. So let's go back to our use cases and see how far the current setup that I've just described gets us. So we see that actually the static config actually ticks a lot of boxes, right? The main one that it doesn't tick is the API facading, because we want to apply client-side routing logic and client-side features such as rate limiting and authentication on the client side, but the clients are not redeployed when the service that they consume is redeployed. So the two life cycles are different. So we can't do the API facading without dynamic reconfiguration of the clients when the provider gets redeployed. It used to be that also we couldn't do gRPC because application load balancer ALBs didn't support gRPC, but that actually changed a few months ago. So now we can do all of those things without the dynamic configuration. In terms of our medium priority things, we still have some gaps there because shards for our tenanted sharding may come and go. So we need a way to update the list of upstream clusters dynamically on all the clients that want to send things to those tenanted shards. If we want to start to do start avoiding some of the cross-AZ costs and load balancing costs, we need to do node-to-node communications. And in order to do that, because nodes come and go, again, we need the dynamic control plane to be able to update all the clients. Fault injection, due to the life cycle, typically doesn't align with the deployment. You want to be able to inject a fault and remove it within the same deployment. So again, that's something you can't really do in an elegant way without a dynamic control plane. In the lower priority things, there are the kind of improvement to developer experience also require that faster config change that you can't really do it at deployment time, or it doesn't really make sense. So really the main drivers for us to need a dynamic control plane are the ability to apply client-side features and allow our developers to have the benefits of internal API gateways without having an actual gateway, the ability to natively support routing to sharded services, the ability to cut on our ELB and cross-AZ costs by going node to node for some services that have high costs, and the ability to run chaos experiments at the HTTP level, as well as some other smaller improvements to developer experience. Atlassian has gotten to a point where the things above are sufficiently highly sought after that we've decided that we want to introduce a dynamic control plane for the service-to-service Envoy sidecars. This should be in your case, you should really make a similar analysis, see what are the things that are actually blocking you, that you need this dynamic control plane. And if you do, then by all means, keep going. So the next step is, you need a dynamic control plane, but which one should you pick? Which one is the best to deliver what you're after? When selecting the technology, we looked at our use cases, but we also looked at all the objectives we wanted our chosen solution to fulfill based on our experience running the platform. We followed the Kepner-Trego decision analysis, which is basically a rational framework around making decisions. So we organized all our objectives, we sorted them between the musts and the wants, and we gave a relative weight to each of the wants. This is an abridged list of the things we considered, but I still wanted to put something out there, right? We required the solution to have a proven track record for handling security issues and scale similar to ours. It had to be resilient to all the expected infrastructure failures, such as instance failure, AZ failures, and we needed to be able to gradually roll out changes and do upgrades without interruption. On the want side, we need to check how well each solution fulfills our use cases that we've talked about already, but we also need to consider things like performance, cost, extensibility, and our ability to troubleshoot. So we had the things we were after, our objectives for the decision. Now it's time to look at what's out there. We know that the list that we went with is not exhaustive. There are other things out there. We also know that some of the decisions that we made in relation to those options are somewhat subjective. This is acknowledged because the whole decision matrix is documented internally. We can always revisit it. If we find that our judgment was incorrect, we can correct. And also in the end, when we kind of rank and rate the different options, we found out that there was a clear gap in how well the valid solution fared. So we know that even if a few things were misjudged, it's unlikely to completely change the outcome of the decision. So we considered to build a control plane ourselves. I mean, we already had done it for the edge, so why not do it for service to service as well, right? Obviously, we considered Istio, we considered AWS App Mesh, Console Connect, Kuma, and Open Service Mesh. When we screened through our musts, we found that Kuma and Open Service Mesh did not meet our requirements in terms of having a proven track record on security and scale, so we eliminated them. Once we started doing the relative scoring of the other option, we found that the cost of building a control plane ourselves ended up causing that option to score pretty poorly. Console Connect also suffered from relatively high cost, and this is in part because we don't run console at all, but we do run Kubernetes API and etcd, and we have plenty of expertise there. And a lot of the features we wanted are not necessarily available out of the box and would have needed us to extend Console Connect, which is absolutely possible through escape hatch and so on, but it just all added up to quite a bit of cost. In the end, timing was everything. When we looked at Istio and App Mesh, and in the last year or so, Istio has tremendously improved its support for non-Kubernetes compute, which is called VM or mesh expansion. It has simplified its operating model, and it guarantees us the possibility to extend and benefit from the support of a large part of the Kubernetes ecosystem. AppMesh, on the other hand, would be massively simpler to build and operate, but critical features are still missing around rate limiting, external authorization, and a few other things. And the story around extensibility is also lagging behind. We're not sure that we're actually going to be able to build the extensions that we need. But the public roadmap for AppMesh shows huge progress. So we suspect that if we had to make the same decision in a year's time, the playing field might be a lot more leveled. So timing was really everything in our decision here. So here we are. We've chosen Istio to make our pudding. We've done a few test cooks internally, but we're yet to really hit it in production and do that in anger. Thank you very much for your time.